morning, everybody. Okay, yes, you're looking up. That's good. We're waking up, get some coffee in the system, and I'm going to start talking in the meantime to keep you busy. I'm going to say some very basic stuff, at least I think so. So basically what I said, my role in this panel is just keeping you awake, getting you awake, and then they're going to say intelligent stuff. I don't, and that's fine. My name is Steph. I'm part of the OSIG. Thank you very much for joining us this morning. We're going to talk a little bit about what are the first steps for a fairer and more efficient research. A few disclaimers before I start. I'm a member of the PhysiPy community. That might emerge at a certain point in the talks, and that might be a little bit of a bias. But especially I have a bias toward open science practices to be better scientific practices. So forgive me if you don't think the same. I would be extremely biased in that sense. And since it's 9 o'clock in the morning, way too early, and you might be a little, still getting some coffee in your system. If you lost yourself while I was talking, I don't blame you, but if you see a green screen, that means that I'm starting to talk about something new, and so you can jump back in with your attention span to the screen. But if you're really, really sleepy, and you cannot really follow anything else, just tune back when you see a blue screen, or that hue. If you're colorblind, I'm very sorry for that, because that's what I'm going to talk about that is very important, and I want you to remember once you get back home, okay? Great. What are we going to talk about this morning with me? We're going to talk about version control systems. We're going to talk about Git workflows. We're going to talk about licenses, releases, DOIs, and then automation. And all of that in 30 minutes or less. So I'm going to speak fast. All right, let's start with version control systems and Git workflows. So how many of you know what Git is? How many of you knows what a version control system is? Raise your hand. Actually, everybody. Okay, great. So for the 3 people that did not raise your hand, I don't know if you're familiar with these situations. This is my old code when I was an undergrad. Like basically I was having super long text files, a lot of commenting because, I had some parts that were important, but I didn't really want to use in that moment. So just commenting, and then keeping it there. Horrible looking. Or maybe you're more familiar with this situation where you have a lot of files and they have basically the same name, but it's just like, you start with one and then you start with the second one and then you save a third version and then you save a fourth version and then at a certain point everything goes wrong. And what do? You restart over. Or maybe you're familiar with a situation in which you were working on something, you want to work on a project, but you cannot work on the project because another person from your team is working not exactly on what you are working on, but it's still preventing you from opening those files. Well, I have good news. This is the cure for all of your problems. This is called a version control system, especially this is Git. It might be intimidating if it's the first time that you see it. It is still intimidating to me after a long time that I see it, but there's a better way to visualize it as well. And it's not the only version control out there. You probably don't know about it, but you're using a lot of version controls in your life. Like, for instance, Google Docs has a version control system embedded. Wikipedia is a huge version control system, and you can check it out. And it's actually very fun to check out the history pages because you see so many things that happen that are hilarious. I invite you to do that. So what are version control systems for the 3 people that did not know about Git before? Version control systems are a way to manage and track changes to file. We call that Git, for instance, and then we have a website that is called GitHub. GitHub is not Git. GitHub is an aggregation delivery system for Git repositories. If you want to have another example of that, it's like YouTube is an aggregation delivery system for content that is videos. Same thing. So Git, you have your version control. GitHub, you have the social stuff on top of your version control. It's not the only version control system, Git. It's not the only aggregation delivery system for Git. GitHub. For instance, we have Mercurial, we have GitLab, we have Bitbucket, we have a lot of other examples that you can choose from or you have to work with in cases of your institution choosing for you. Now, why do I like version control system again? Because of the file history. That's a huge help. So for instance, you can see when you add stuff, you can see when you remove stuff. That means that at any time, if I want to get back that class that I deleted in this slide, I can do that. I can just go back, scroll back in my commit history, take back that commit, and that will be there. I don't have to comment it and make my code look ugly instead. So take-home message number 1. Let's see if you're focusing on the screen again. Yes? Yeah, that's working awesome. So working with VCSs allows you to track changes and authors and work in parallel without disruptions. And as a bonus, I love it because it forces my team to double-check projects before we push them out. It forces my student to go through a process of revision from me, which normally means I'm late and they hate me for that, but that works. Let's talk a little bit about licenses, releases, and UIs, because at a certain point, if we want to become fair, we have to expose ourselves to the public. So first things first, though, a little disclaimer, I'm not a legal expert, so please double check what I'm about to say with your technology transfer or library office. It's very important. All of your institutions have something that looks like that. They deal with licenses far better than I can in 30 minutes. Let's talk about licensing your work. Why do we want to license our work? Because a work that is not licensed is not public. It's paradoxical, but basically the license is an instruction manual on how people should interact with your work. And so for instance, that's why all of my slides, well, all of my talks have a little disclaimer at a certain point. That's my license, and that's there to stay, because then you can reuse it. There are many licenses they can choose from, open source or not. And they're not just code related. If you don't know what license is best for you, you can check this website. It's called Choose a License. I know a lot of creativity there, but there's going to have a lot of examples of licenses that you can adopt for your code. There's going to be a lot of explanation of the licenses that you can adopt for your code. My personal picks are Apache 2 for code and CC by ND for non-code, basically documents, images, and stuff like that, for very precise reasons that I'm not going to mention now, but if you want to ask me later during the coffee break, during the Q&A, and I'm going to explain. And importantly speaking, if you're using a VCS, the license should be in the first commit that you make, because you want the first moment of your history of your repository to have a license, so that people cannot go to a previous version of your repositories to say, this was not licensed, I can do whatever I want with it, right? Now pay attention, because licensing is very, very headaching. There are licenses that you can use in conjunction with other licenses. This is a table. I'm going to share the slides with you at the end, so don't worry about it. But this is a table that shows, for instance, some licenses that you can use in terms of on the rows, there's the license of origin. So like if you're using, for instance, somebody else's work, what was their license? And on the columns, you can see what licenses you can use for your own work that is considered a derivative of that work, of that original work. And so there are many different options, and you can see, for instance, that all the GPL licenses that are normally the most open source strict licenses allow you to use only open source strict licenses, so GPL themselves. And then you have some more permissive type of licenses that are open source, for instance, BSD, MIT, Apache, et cetera, that will allow you to use a bit more licenses than the one before. But it's important to pay attention, because licensing, like clashing between licensing between derivatives might become a problem for you and your users especially. So if you do borrow some code, if you do borrow some libraries, especially for instance in Python, we import a lot of libraries. In MATLAB, I don't know, like 10 years ago when I was using MATLAB, there was this horrible idea of just taking files from the systems, taking files from the editors, like taking files from other packages and then putting it there in my package, because that was a fast way to do it. I hope that's not the case anymore, but I'm not using MATLAB since a while. But check the license of the code, of the data, and the libraries that you are borrowing or using or importing. Pay attention to single versus double licensing. For instance, FSL has a double licensing, one that is free, sort of free and usable for you because you're an academic, one that is licensed and pay for use because it's for industry. Check the license compatibility. If you want to import something in your system that uses GPL and you want to import something that uses BSD, you cannot do that. You will have to choose the license that you want to use, because some licenses are not compatible between each others. And remember that institutions might have rights to what their employees do. So your university, your employer, has rights on what you produce. For instance, this is something that was taken from my contract from when I was working at APFL in Switzerland, and it states clearly that APFL is the owner of its employees' invention and software, which means I am not licensing alone, I'm licensing with them. But the good news is that they can help you with licensing, so once more, check with them, and also they can help you with license enforcing, which is normally not a fun thing to go through. Also, license your work in the right way. So put a copy of the license or a link to the license that that code used as close as possible to the borrowed material. If not in it, if you're using a code that doesn't have a license inside, feel free to put the license inside. That's a nice gesture. If any license requires its adoption for derivatives, so for instance, if you're using GPL material, you must license your work with the same license. So you're using a GPL material, you have to license in GPL. You can ask, though, the original authors to change their license to a more permissive license, or you can give you can obtain special permissions. That normally happens to me lately. I ask a lot of people that release in GPL if they can move to a more permissive license. Normally they're like, yeah, in my youth I was a bit more, on the side of GPL. Now I'm a bit more calm and I can use more permissive licenses. And that's nice. And remember to add licenses disclaimers in all of your files. This is a GitHub page. That's a license on GitHub, on the repository. That's a license on the page itself there. That's not enough. You have to put it in the code, especially Apache 2 will activate only if you put it inside the code itself. Once you have a license, and you're a happier person for it or not, depending on the case, you have to release your work, you have to release your software, you have to release your publications, your documentation, everything that you're working on. Because making your project public is important. So it will attract more users, it will attract more readers, it will attract possibly more contributors. Releases are basically a freeze moment of your deliverable. So for instance, if you have a code and you want to use it for a paper, you can just create a release that shows the code that you used until that version for that paper, then continue working on that repository without having to change, without having to duplicate, and then at the end of the day, create a new release for your next paper. So if the project is a code-related project, you can also distribute it once you have a release. So for instance, with Python packages, you can create a little script, a little workflow for the release to become a PyPy package, and then that will be also listed in PyPy. But more importantly, why do we want to create releases? Because that gives us versions, and that gives us the possibility to identify our projects, our deliverables. So how do you do that? Most of the time, there's many different options that you can adopt. My favorite in this moment is Zenodo. I don't know if you know this platform. It's supported by CERN. And basically what it does, it gives a DOI, a digital object identifier, to any possible thing that you're doing. So when you set it up, you can set it up with an automation for GitHub. It will give you a file that looks like this one. It's a JSON file. You can put it in your repository in GitHub, and once you've done that, it will, like Zenodo, will automatically look at your releases from your repository and will create a new DOI every time that you will create a new repository. If your project is code-related, you can think about publishing it. There is a journal that is called the Journal of Open Source Software. It doesn't cost anything to submit. At least the last time that I checked, it didn't cost anything to submit. You can do it for free. It's all based on GitHub, so basically you just go through a PR, and they will just accept your publication as long as they're happy with how it looks. It's fairly fun. You can try it. I did it before. I survived. It was actually a very nice process because our reviewer gave us a lot of feedback on how to improve our code. So take-home message 2 of the day. Go public, license your work, create a release, and assign a digital object identifier to it. You're going to be happier for that because that's citations. Now let's talk a little bit about automations because I'm a lazy person. I don't want to do all of this stuff by hand every time. So I let CI/CD workflows do it for me. CI/CD workflow, what does mean? CI means continuous integration. That's basically the frequently interacting new changes into the main branch of a tool. So for instance, there are workflows that will run automatically steps at each integration. For instance, automatic testing, for instance, some code checks, for instance, some code styling. And then we have continuous deployment. That is basically the idea of frequently deploying or releasing new versions of your tool on using automated workflows. So again, for instance, creating a release, creating a digital object identifier. That's the continuous deployment. Workflows are not super easy to implement the first time, especially if you're a first-time user, but once you set one up, you're going to be happy for that because it's going to save you so much time in the future. And so try to do that. It's normally fun. If you have any problem, you can also speak with me and we can chat about it. Now, this is one of my favorite workflows. It's called Auto. Auto is basically a package that was created by Intuit. And what it does is basically it helps me to release constantly everything that I do every time that I close a pull request. So somebody opens a pull request, it goes through it, I assigned a label to it. That's very user-friendly. Like my first-time contributors can do that themselves. They don't have to think about writing special things in the title or writing special things in the text or format things in a certain way. It's just going to pick it up from a label, and it's going to give me a release with a link, with the type of release based on the label, with a link to the PR, so that people can go in the PR and look what happened. And so basically that would both create my releases and my, how do you call that? The changes file. So people are aware of who did it, when they did it, and how they did it. That's amazing, just check it out. And this is my second favorite tool. Actually, this is my first favorite tool. I'm not going to joke. Pre-commit. So pre-commit is a Git hook. I don't know if you're familiar with Git hook, but it's basically small workflows that run every time that you make a commit. And it can run so many different things, and that's why I love it. It can create local and remote simple automation. So basically, every time that you commit on your computer, if you installed it on your computer, every time that you're committing it to your repository online, if it's just online. But what it's going to do is, for instance, code styling. If you're working with Python, you might be using Black, you might be using isort. Pre-commit runs it for you. File checks. For instance, you can check if there are empty lines in files that shouldn't have empty lines. They're going to check indentation for Python packages. It's going to check if some files are executables when they should be or when they should not be. And especially, I'm not a my English is not my first language. I make a lot of typos. I make a lot of language mistakes. There's ways to run small workflows with pre-commit that will correct those mistakes for me. And normally, my friends that speak English appreciate that. How do you use it? You basically just install it with pip. You then move to your repository. You initialize it. You create a little configuration for it. There's a lot of different things that you can use in it. Like in the pre-commit page, you're going to see all the hooks that you can install, and that will be run automatically by pre-commit. And it's seriously a no-brainer to use. So I invite you to try it out and install it and go for it. So what are the other possible automations that we can use? I talked about pre-commit right now. I normally run tests on my code and on my documentation, and we do that with CircleCI and CodeCov to check for the coverage of my packages. We can do versions and releases with Auto and GitHub. Actually, GitHub is already great in those terms. We had digital object identifiers with Zenodo. And finally, we have documentation that is released constantly and automatically with read the docs. I'm not going to speak about read the docs now, just for a matter of time, but again, if you have any questions, just ask us, we can talk about it. And let's not reinvent a wheel. There are so many workflows already available for you out there. They're going to be on the GitHub Marketplace. Check it out. There might be already what you're looking for without you having to set it up by yourself. So take on message number 3, set up workflows to test, build, and release, publish your project. They will not only help you, but they will increase the stability and reliability of your outcome. And especially automate, automate, automate everything, because our life is too short. You don't want to do stuff by hand. That said, thank you very much for your attention so far. I just want to thank a couple of people that worked with me so far and with which I learned a lot of these things. For instance, the PhysioPy community here, my SIG, the OSIG of this year, amazing team, and all of my collaborators, students, and friends, and groups. And if you have any question, you can take the QR code. You can scan the QR code to access to the presentation that I just gave. There's also a few more slides that I didn't present. So please feel free to get that. And if you have any questions, I have some time. Do you want to do it now or no? Later, during the QA? During the QA, I'm going to be there sitting down, and you can ask me questions. Thank you very much.